Dear students, I am Rishmi. Now let's continue with unit group theory. First of all, let's revise what we have already studied in the earlier classes. The most important part of group theory is there are two terms, symmetry operations and symmetry elements. What is a symmetry operation? Symmetry operation is a well-defined, non-translational movement of an object that produces a new orientation that is indistinguishable from the original object. That is, we are performing an operation such that the object as a whole is not moved from one place to another, but it produces a new orientation which is indistinguishable from the original object. And next is symmetry element. What is a symmetry element? It may be a point, a line, or a plane about which the symmetry operation is performed. We'll be performing the symmetry operation either about a point or a line or a plane. And these three are the elements of symmetry. It may be a point, line, or a plane. Okay, we have an example here. You can see this triangle, and the dotted lines are passing from one vertex to the edge center of the opposite side. And this line is the symmetry element about which you can see this curved arrow. It indicates that we are rotating the object, and the arrowhead is towards the left side. So we are rotating the object in the clockwise manner. Either we can rotate in the clockwise direction or we can rotate in the anti-clockwise rotation. But what we have to be careful is the whole rotation should be either in the clockwise direction or in the anti-clockwise direction. The whole 360-degree should be either in the clockwise direction or in the anti-clockwise direction. Here we are rotating the molecule in the clockwise direction through 180-degree, and we are getting a similar appearance. This is the new orientation which is not which is indistinguishable from the first one. That is, we don't know if an operation has been performed or not. And that line is the symmetry element, and what we have performed is rotation, and that rotation is the symmetry operation. Here we have the symmetry element as plane of symmetry. You can see here it's a water molecule, oxygen in the middle and two hydrogens on two sides. And to distinguish the two hydrogens, we have given a color. One is red in color and the other is blue. And this is the mirror plane, or this is the plane passing through oxygen and in between the two hydrogen, or you can say the plane passing through oxygen bisecting the angle between two hydrogens, or HOH angle is being bisected. And what happens when this plane is placed here? We get the reflection of the blue hydrogen on the left hand side and the reflection of the red hydrogen on the right hand side. And what have we performed here? It is a reflection. And here reflection is the operation and the plane is the element of symmetry. And we can see this water molecule here, same with oxygen and two hydrogens. If the hydrogens were black in color, both the molecule, the one on the left hand side on the right and on the right hand side, would appear as indistinguishable. This is for you to know that we have given it a color. So how do we define the element plane of a symmetry? Plane of a symmetry is an imaginary plane passing through the molecule which divides the molecule into two equal halves or two mirror images. Next symmetry element is the first symmetry element was rotation. Here we have seen So how do we define this rotation? The or line of symmetry. Line of symmetry is defined as the imaginary line passing through the molecule or an object about which, when an object is rotated, gives an indistinguishable appearance or gives the same appearance. Line of symmetry is an imaginary line passing through the molecule about which, when the molecule is rotated, gives a similar appearance. That's the definition for line of symmetry. All these elements, the point, the plane, the line, are all imaginary. So everywhere you should mention it's an imaginary point, or it's an imaginary line, or it's an imaginary plane passing through the molecule or passing through the object. Okay, next is inversion center or center of symmetry. Here, taking this orange ball, this molecule is actually SF6. It's octahedral in shape. You have the orange one, that is sulfur, in the middle, with it is surrounded by 6 fluorine atoms in the octahedral shape, or you can call it square bipyramidal. This is the square. The square is formed by the fluorine atoms 2, 3, 4 and 5, and the pyramidal shape by 1 and then 6. Okay, here, what is center of inversion? It's a line drawn through a point in a molecule. It's a line drawn through a point in the molecule and extended in both directions encounters equivalent point in either. The point through which the line is drawn is called an inversion center. Okay, taking this sulfur as this inversion center, the line drawn, we can take the line drawn as the line joining 3 and 5. A line drawn through a point, the sulfur is the point, through a point in a molecule and extended in both direction encounters equivalent points. That is, it meets two similar points in both direction or in opposite direction at equal distance. Then that point is called the it's called the inversion center or center of symmetry. Okay, next we have the symmetry element called identity element. Identity element is just like we have 1 in maths. When we multiply any number by 1, we get the same number. Similarly, identity element is a symmetry element, and or we can say identity operation is an operation which, when performed, gives the same appearance as the original object, and it is actually considered as doing nothing. We are not doing any operation on that molecule, and every molecule or every object has this symmetry operation called identity operation. Okay, this is an operation which brings molecule back to its original orientation. This operation does nothing. That's the most important. It is simplest of all the symmetry elements. It is the only element or operation possessed by all molecules. It's possessed by all molecules or all objects which doesn't have even any symmetry. Okay, you can take this molecule here. It is it's carbon in the middle, and we have a hydrogen. Then the other 3 balls or other 3 atoms are fluorine, chlorine and bromine. Fluorine, chlorine and bromine. See here, it is 1 chloro, 1 bromo, 1 fluoro, methane. So we have carbon in the center. Okay, in this projection we cannot see hydrogen. Hydrogen is towards the it's away from the plane. So here we have fluorine, chlorine and bromine and hydrogen attached to this carbon. So there is no symmetry. But still, what does this molecule possess? It possesses identity element or identity operation. An identity element or identity operation is doing nothing to that particular object or a molecule. So far we have learned the symmetry elements of rotation. Symmetry elements, line of symmetry. Then we have plane of symmetry. Then we have the center of inversion. And now we have learned identity element. This identity element is always mentioned as the first element. Next one is improper rotation axis. Improper rotation axis. What we have learned first was rotation axis or proper rotation axis. And that's the imaginary line passing through the molecule about which when the molecule is rotated gives similar appearance. And let's see what is